Hi, my name is Tanmay Bhattacharya. Let me give you a very quick demo for the project I'm working on. It is an order book and matching engine, which is a financial app in which people are able to give orders for certain assets that they either wish to purchase or sell. And this app, what it does is that it allows the end user to make orders and see how his orders are being fulfilled. Behind the scenes, the app will take orders from multiple parties and match them in such a manner that there's a maximum spread. All right. So let me just make a quick go through this. And remember, this is about 80% completed at this point. So what I have lacking right now is two main things. First thing is security. So I will be putting authentication and security into this. And finally, once that is complete, I will be pushing it to AWS. Those are the two things lacking. But right now, what I have present is I have the microservices structure. I have two microservices running. One simply gathers the orders given by the front end, which you're looking at right now, and the another and it feeds that to a Kafka queue. From the Kafka queue, a second microservices, which is the matching engine microservice, it gathers all these orders and it does all the matching between the two orders. So aside from that, which is the Java services, Spring Boot microservices, aside from that, it also uses Kafka for a messaging queue, and it uses MongoDB as an NoSQL database to push all the transactions. That is the first thing. Second thing is that is the backend. For the front end, we have a Next.js app. The Next.js app, let me just show you quickly. It has it's running right now. So basically, it's your standard 15 Next.js 15 app, and I'm using TypeScript as is good practice, and using Tailwind. If you look at the, let me show you. Yeah, if you look at the screen here, it's using Tailwind for its styling. That is the front end. It's running right now. For backend, I have a plain old Spring Boot app, and the main microservices are the two main microservices. The order front, which actually has the controllers and takes in the orders from the front end, does checking to make sure that it's valid, and should they be valid, they shall be pushed into a Kafka stream. And this matching engine, this in turn takes in all the orders and from the Kafka stream, and it does the matching. So if we look at it, if we look at it, this is one of the core classes. So in this class, if you can see, well, I'll actually discuss the data structures. I don't want to go through code line by line. That probably will take a long time. But this is one of the main core components, and everything is put into this. And I'll discuss it later. Again, I'm going to clean this up a little bit more. I'm still going to put in security and do the testing. But right now it's still functioning, so it can be shown. So let me just go with that. So right now, let's say I want to buy an asset. Let me say Tata. I want to buy it, bid. Say I'm willing to buy it for $100, rupees, whatever the currency is. Volume, let's say I'm willing to buy 50 of these. And let's say my designation is Atlas 0. Again, once I put security into it, which will be using Keycloak and JWT, there will be a login screen and this client ID will be fixed. We cannot change it. But right now, just excuse it for the time being. This will be put in within 2 or 3 weeks. I'll be gone for 2 weeks to Kashmir. Once I come back, I'll put those features and I'll upload a new video with this. So once I do this, you can see I'm here in a transaction screen. Transactions are the trades that have already been made with a counterparty, but I have none. Because I freshly started the system and there's only one transaction that I have made, so there's no counterparty available, therefore there cannot be a transaction. So if I go to the pending order screen, I can see that this is a transaction I made. For Tata, I'm willing to buy 50 of these at this particular time, and this is the timestamp. Right now, if I go back to the order screen, and again, I'm taking a bit of a liberty here just for demonstration purposes. Let's say for Tata, I'm willing to sell rather, for a mere 50, I'm willing to sell, say, 5 units, and this time I will call myself, say, C1. Just a name given. This will be this will not be controlled from the interface once the security features are put in, but for the time being, just to show the core features, I'll go through this. Now a transaction is done. Transaction volume is 5, amount is 50. All right, because right now I'm putting this in as C01, and if I go for pending orders, I have no pending orders because my transaction was completely done. If I go back again, suppose I want to put it for a different screen just to show something, which I'm willing to ask for, say, 200, for whatever, and 12, and I go back as Atlas 1, I go back, no transactions. I think I used Atlas 0 last time, so let me go back. Again, say Sync 3, bid, amount is 12, volume is 12, client ID Atlas 0, and I submit. Okay, this is the first thing I did. My transaction amount, I was able to sell it for 100. The volume was 50. If I go for my pending orders, these are my pending orders. So yeah, this is just a quick show, and let me just show you my GitHub where this is. If I go to my GitHub, this is it. So the reason I'm going to my GitHub is because I just want to make a quick walkthrough with the README, which is a bit detailed on the architecture part. So like I said, if you look at the tech tech stack at a glance rather, the front end is the Next.js 15 app. The microservices are Spring Boot apps. There are 2 microservices right now. OrderBook, which collects the front end and passes it to the rest of the system, and there's the matching engine, which performs the actual matching among the different bid and ask orders. Kafka is used for the async messaging within microservice system, and we're using protobuf for more efficient message passing inside our microservices. So if you look at the diagram, let me just expand this a little bit. So I'll have a bunch of Node.js apps, Next.js apps. These are my front ends. They'll be going through load balances into the API gateway. And with load balancing, these will be going to my front end microservices. These we can scale as per the traffic, and they'll be going to the Kafka. Now in Kafka, again, depends on the traffic. The way I'm thinking of scaling it is simply to have more brokers with more partitions. And the way this thing is going to run end to end is that our final microservices, the matching engine, which will be the consumer, these will be divided based on the asset tickers. Like we just showed Tata, but it could be anything. Now, because our asset tickers are string, we can basically divide them by the first, by say, like in alphabetical order. So AAPL Apple could be in one group, and depending on how many services, how much traffic we can basically put into different buckets, different tickers, and these will be fetched by different microservices. So if we have two microservices, maybe tickers from starting with A to say M would be in one, the rest could be other, and we could go through them the way it's going. And if one or two particular stocks are extremely heavy, they could maybe even have their own microservices. So these are going well. And in the end, these are all going into the MongoDBs, where the transactions are pushed. So this will be the scaling strategy. I will not read them line by line. I've basically discussed them here. They're simply in the GitHub's README. And now let me go to the data structures and how we have designed them. So how I have designed them. So like I said, the very top will be asset tickers, say Apple, Google, Microsoft, whatever. These will be the topmost hash map. For every ticker, we will have a hash map once more with only two keys, bid and ask. This is to make sure that our bids and our asks are segregated and easily traversed individually without having to go through one large tree all the time. Since it's the way we are operating, we will often have to counterbalance the bids and the asks. So we'll have the bid and ask again in the hash maps. These will be string keys. And for every key, for bid or ask for a particular ticker, say they're Apple or Google or Microsoft or whatever, they will have a tree map. A tree map in which our keys will be big decimals. So the big decimal is there to have the price. So different prices are there. And what we have done is we have used two custom comparators for the bids and the asks. So because we want the highest bids, we want the lowest asks to be compared as much as possible. But due to that reason, so we can traverse more efficiently, we have used custom comparators to make the tree maps go in this opposite manner. And for each tree map, the price point is the key, the big decimal. And with that, for the value, it will be a priority queue. So a priority queue will have all of the orders for the same, again, if you go for the same ticker, for the same asset, whether they're bids or asks, and they're also for the same price point. But the reason we're using a queue is that if we have several orders in which they're all of the same ticker, whether same bid or ask order type, and same price points, we want to order them by time. So the priority queue will be following the timestamps, and they will be ordered accordingly. So that is one of the ways of pushing the prices in such a manner that the earlier orders are taken care of first, and so on and so forth. So again, I will not read this text line by line, but I've pretty much discussed them, and I think they're easy to read at this point. So that's it. Thank you so much. I won't take too much time. I request you to please take a look at the apps. The code is here in my GitHub. As you can see, and basically in my resume, this GitHub link is also there, so you can take a look. And thank you so much. Thank you for your time. I will take a leave now. Thank you so much.